This session is going to be very important for you in system design interview. Recently, I've worked through my Google interviews and lots of other interviews before that in the top companies. And this was the one skill which really helped me a lot. The back of the envelope calculations. So in this session, we are going to see that why this particular skill is important. We will look through some important numbers that we must remember. The almighty power of two table, which is going to help us in any kind of calculations. We will see examples that how many servers do I need for computations or for storage. These are the most frequent calculations that we have to do during the interviews. How many bytes do I need for a specific variable? Then we will do some hands-on exercises, and then we will see the process of mastery, that how we can master this skill. Okay, so let's see why this is important. First of all, it is not an integral part of the interview. When I say not an integral part means you are not going to earn any brownie points if you ace it. But definitely it's a big red flag if you don't perform well here. And the second thing is that you want to get done with this part of the interview as soon as possible. Because if you are able to do it, if you are able to nail this part, then it shows that you are awesome at resolving ambiguity. You know, in interviews, somebody gives you a problem, design Netflix, and you work through the ambiguity, you identify that how many servers you would be needing, what kind of storage servers you will be taking. Then you can show that you are able to solve ambiguity. Secondly, the most important thing, it saves you time because you want to save the time and spend on the other critical parts of the system design interview. And third thing, that if you crack this thing early in the interview, then it will help you to boost your confidence. And once you have good confidence, it's very highly likely that you are able to translate it into a good performance. Okay, so with that, we go to the next part. Okay, some important points to remember. So first one is the planetary round trip time RTT or the latency is 500 milliseconds. So these are approximate numbers. It could be 400, it could be 600, or it could depends on various other factors like what kind of network you are using. But we can take this 500 millisecond number as a rule of thumb, and we can use it during the interview. Then the another very important thing that comes is that how much time it takes to read from various sources of data, how much time it takes to read from RAM or SSD or network. Now, why this is important? Let's say you are in middle of a question and you are deciding that are you going to store that data in RAM in a Redis kind of data memory store, or you are going to put in a Cassandra kind of database which is SSD backed, or you are going to do it in old style that you are going to put it in some kind of disk-based data structure. So that's where these numbers are quite important. So if you look at the numbers, from reading 1 MB data from RAM sequentially takes 0.25 milliseconds. From SSD, it takes 1 millisecond. Right? So RAM and SSD, they are not very far. And again, these are the not exact numbers. These are your mileage may vary kind of numbers, but we don't need to bother about it. We can take these numbers as rule of thumb. So reading 1 MB data from 1 Gbps network, it takes 10 milliseconds. Reading from disk, it takes 20 milliseconds. Now you can see that why caches are so effective. Because cache is 80 times more fast than a disk. And let's say if you have to identify that, okay, I'm going to use a distributed cache like Redis, then how much time fetching 1 MB would take? So we can take a very educated guess here that it takes 0.25 milliseconds to read from RAM, and it takes around 1 to 5 milliseconds round trip time between application server and Redis server, given that they are in the same data center. So within a data center, it takes only 1 to 5 milliseconds. Right? So that's why we hear that distributed cache or Redis, they have latencies in single digits. This this is how we derive that number. Okay, so let's move to the next one. Okay, so these numbers in this slide are again very important. These numbers are going to help you to do very quick calculations. So hours in a day, let's reset our knowledge. Let's say it's 25, it's not 24. Days in a year, 300. It's perfectly fine to take it as 300 in calculations. No need to stick to 365 or 366 in some cases. When you are doing calculations for the multiple year, that in 5 years or 10 years, how much data I'm going to need or how many servers I'm going to need. In that cases, we can do it like this, that 3 years is 1000 days, 6 years is 2000 days, 9 years is 3000 days. So that's going to ease our calculation. Yes, so Sankalp has asked, wouldn't be 400 be simpler and more accurate? Yeah, 400 also makes sense. We can go with 400 also. So then the idea is to do ballpark calculations. So 400 is also fine. Thank you for answering, questioning that. In one day, we have 86,400 seconds, but we can take it as 100,000 seconds. This one we all know, but we should keep it at top of the head so that we don't have to recollect it during the interview. It is just served from the cache directly, that 1 second is 1000 milliseconds and 10 to the power 6 microseconds. Yes. Then the next section, that what's the capacity of a one commodity server? This is also very important. It will really help you to do quick calculations. Sure, I will. And Nagarjuna has asked that can we have access to the slide? Sure, I will share it. So one commodity server, we can take a very good assumption that it has 100 TB terabytes of disk. It has 128 gigabytes of RAM, and a server has 32 cores. And one core can run 8 threads per core. So again, the number 8, it is a very approximate number. It depends on the kind of application, it depends on the language that you are using, because in case of Java, they are going to be very heavy threads. In case of maybe Golang, they are very lightweight threads. But for the purpose of interview, it's a it's an acceptable number. So 32 cores into 8, so that means 250 threads. Okay, by one core, I mean one CPU, the one processor. Yeah, I'll make this amendment in the slide also. So that means one commodity server can serve 250 threads at a time. Then there are some questions around the chats, that how do we design the chat system. In those cases, WebSockets come into the picture. So these are actually WebSockets. So we can have 50,000 WebSockets at a time in a one commodity server. Yeah, let's move to the next part. Okay, so for questions where you have to say you have to design Instagram, or you have to design YouTube or Netflix, so we have to take some assumptions about the numbers. So the ideal way is that you ask the interviewer first, and in many cases, interviewer is going to give you some approximate number to work with. But if they do not give that number, in that case, these are the safe assumptions that we have 500 million overall users and around 200 or 250 million daily active users. Then second thing, usually that the reads are much, much, much higher than writes. So for example, social networks or Twitter, let's say, one person sends a tweet, and if that person has 100 or 200 followers, then that one write is going to be read almost 100 or 200 times. Right? So that's why in some cases the reads can be 1,000 times of writes. So this is why when it comes in the interview, we should be very careful about the part where reads could be much higher than writes. So we have to do the calculations for that much more carefully, and we need to make sure that the number of servers and those things are taken care of. Okay. Then in cases of uh, Netflix or YouTube, where you upload a video or download a video in chunks, even in some cases, like if you're designing S3 kind of system, so you have to download a heavy document, right? So what should be the chunk size? So there have been a lot of studies and experiments around this. There are some good papers also. So the bottom line observation is that this ideal chunk size is 100 KB to 10 MB. If you go less than 100 KB or if you go higher than 10 MB, then you are at the risk of doing a lot of disk reads. There, So that's why this number is most optimized for disk seek time. And if we look at the graph where that how much time it takes to read this chunk from the disk, then 1 MB is the elbow point. So after 1 MB, the number starts increasing more gradually. So you can say 1 MB, 2 MB, these are the good numbers for a chunk size. Okay. This table is the most important table, the power of two table. I'm sure we know this stuff, but these numbers should be tattooed on our brain. Even if in sleep somebody asks you that what's 2 to the power 30, you should say that it's 1 billion, it's 1 gigabyte, it's 10 to the power 9. So we have to memorize these tables to that extent. So we all know that 2 to the power 10 is 1024. So that's lump sum 1000. So that's 10 to the power 3, 1000, 1 kilobyte. So 2 to the power 20 is 1 million. It's 1 MB. 2 to the power 30 is 1 billion. It's 1 GB. We know this stuff, but please take a printout of this table and paste it in on your wall and keep revising it. Okay. So we come to the part that how do we calculate that how many servers are required for a throughput? Okay. So we can say that a request served by one thread in 1 second. So okay. So let's understand it more. Just a second. Okay. So let's say we have a one thread. Is it visible? Okay. I need to change the color. I think. Yeah, this one is more visible. Or let me change the. Okay. This should be more visible. Okay. So let's say we have one thread, right? Now this one thread could be serving, let's say some API calls are coming to this thread. So at a time, this thread is going to serve one API. So, and let's say it takes 200 milliseconds to serve one API, right? So in 200 milliseconds, the request comes. This is the thread. It accepts the request. It does some background processing, and then it returns the response. So let's say this whole operation takes 200 milliseconds. So that means in 1 second, how many requests we can serve would be 1000 by 200. Right? So that means 5 requests can be served by a thread in 1 second. Okay. And then during interview, we also need to sometimes identify that, what would be the expected latency of the core API of the system. Yeah. So if it is a customer facing application that you are designing, let's say you are searching something on Amazon e-commerce. So these are customer facing apps. So in that cases, ideally 1 to 200 millisecond is the ideal latency. Of course, 1 second, 1 millisecond, 2 milliseconds are very difficult numbers to achieve. But what happens that after 200 milliseconds, the customers, the clients, they start noticing that the system is delayed. So that's why 200 milliseconds is the maximum number in case of customer facing apps, right? Then we need to run our servers at 50% CPU threshold. Now it also depends on the requirements that sometimes some companies they like to run their uh, systems at maximum 40% CPU. Sometimes some companies they go till 60%, 70% also. But for easier calculation, we can say that 50% is a good number, right? So now if we have to find the number of servers, so this becomes the formula. And we don't need to learn this formula. It is just a very logical and very common sense kind of formula. I'll just explain it. So so what's the total expected query per second the system is going to experience? So either your interviewer has provided this number to you, or you have taken an educated guess. Then you divide it by the request served by server in 1 second. Right? So so that means how many threads are there and how many requests that those threads are serving in 1 second. Divide by 50%. That gives you the number of servers. Don't worry if you are confused somewhere in this formula. We will do a hands-on exercise for this. It will be much clearer then. Okay, so yeah, just worth explaining. One more thing. Why we take 50%, right? In case it's not clear. So so let's say your servers are running at 70 or 80% of CPU capacity, and suddenly you have some unknown spike due to some kind of event which you had not foreseen, and your traffic increases from 1x to 1.5x, so it has become 1.5 times. So in that cases, the extra requests that are coming to your system, you need that extra power to serve those requests. So that's why it's very preferable to keep running your servers at 40% or 50% of CPU. Okay, so similarly, how do we calculate that how many number of storage servers are required? Right. So in this case, first we estimate that what is the total data size that is required. So we will see an exercise that how do we calculate this that total data size requirement. So once you have identified the total data size requirement, you divide it by 100 terabyte, because we know from the previous slide that 100 terabyte is the disk size of a commodity server, right? And we divide it by 70% then. Why 70%? because 70% is ideally the maximum disk size that we should fill. Once we go above 70%, like 80% or 90%, so if we have filled a disk to that capacity, then the reads and writes, they start slowing down. So because the seek times start increasing. Okay, how many bytes should we have for ID variables? Some kind of identifier variables. And this is a question that comes very often to our mind when we are doing the schema design. So let's say you are finding that how many users would be there on your system. So let's say you are designing Instagram and you have identified that you are going to have a users table, and that users table has to have a primary key, the user ID. So in such case, you can start with the assumption that okay, let's say there are 100 million users in 1 year. Then if you look at next 5 years, right, you can say that okay, these 100 million users are going to increase to 1 billion users. So that means we need a number which is good for counting one more than 1 billion users. Right? And if we remember this power table, right? So 1 billion corresponds to 2 to the power 30. So the 30 here is the 30 bits. Right? So that means 30 bits are enough to count up to 1 billion. So if I have a 32-bit number, then it should be good enough for 4 billion users. Okay. Now for counting big numbers like tweet ID. Now in this case, you need to have a counter which is going to help you to count some huge, really huge numbers. Right? So if we look at the power table, right? So the 52 to the power 50. This so that means if I can have 50, if I can have 40 bits, this is like 1 trillion. Right? So that means I can store 1 trillion tweets. But the kind of crazy pace at we the tweets are going on, it seems very logical that 1 trillion is going to be a small number. So if we can have 50-bit number, then it can count up to 1,000 trillion. So 1,000 trillion seems like a good number. And if we look in the reality, so Twitter uses a 64-bit number. And 64-bit number just makes them future proof. So yeah, so in the interview, you can instead of directly saying that okay, I'm going to use a 64 bits number, if you can very quickly reference this that to the interviewer that okay, if I can have a 50-bit number, then it gives me the capability to store 1,000 trillion tweets. And yeah, and then if I go to 64 bits, then it makes me future proof. Then okay, I'll go with 64-bit number here. Okay, so let's go to the exercise now. So let's consider below numbers. So we have 500 million daily active users, 100 million photos are being uploaded per day, and average photo size is 200 KB. So let's say you are designing Instagram like application, and these are the numbers you have come up after a discussion with interviewer. Maybe you came up with the number of daily active users as 200 million, and maybe your interviewer said, no, maybe let's make it 500 million. Then 100 million photos uploaded per day. So this can also come from you can take a very educated guess here. Let's say you came up with, okay, there are 200 million daily active users or 500 million daily active users, and one out of 5 person is uploading a photo per day. Yeah, then that comes to 100 million photos uploaded per day. So again, in reality, it could be 200 million, 300 million, or 1 billion, but for the purpose of interview calculations, it's perfectly fine. And then average photo size, it let's say if you are again, we can take it 200 KB, even you can take it as 1 MB also. Again, that is also fine. Right. The more important thing is that how do you do the calculation from these numbers? These numbers, if they are in vicinity of correctness, you are good with it. Now we need to concentrate that how we can do the fast calculation. Okay, so okay, so we have to identify that. Okay, I'll put the numbers here again. So we have 500 million daily active users. We have 100 million photos uploaded per day, and size of photo is 200 KB. Now the question is that how much data is required to store photos in future? Now future, generally you can say that 5 to 10 years. So now let's calculate that how much data storage is required in 1 day. So 1 day. So we know that one photo size is 200 KB, and we know that 100 million photos are being uploaded per day. Now, how do we quickly convert it into an actual number? So the important thing here is that we should be thinking in terms of power of tens here. So what we will do is that we will convert this expression into power of tens. So this becomes 2 into 10 to the power 2. So this 200 becomes 2 into 10 to the power 2. And then the KB, we know that it is 1000 bytes, right? So that is 10 to the power 3. So this becomes 10 to the power 3. Then again we have 100, which is 10 to the power 2, and million. So again, if that power table is is sitting in your mind very clearly, then you know that million is to 10 to the power 6. Okay? Right. So these many bytes you would be needing in a day. Now um, if we know the power table, right? So it's 10 to the power 3, 10 to the power 6, 10 to the power 9, 10 to the power 12, 10 to the power 15. So this is kilobyte, this is MB, this is GB, this is TB, this is petabyte. So in calculation we have to come to the closest lower 10 to the power. Right? So if we count the number of tens here, so 2 plus 3 5 plus 2 7, 7 plus 6 13. Right? So 10 to the power 13. So that means the closest and which is lower than this is 10 to the power 12. So so 10 to the power 13. So I can write it as 10 into 10 to the power 12, and this 2 is there, right? So that means 20 into 10 to the power 12, and 10 to the power 12 we know is terabyte. So it is 20 terabyte. Now this is for one day. Now how do I calculate it for 5 to 10 years? So the trick here is that instead of thinking about 5 years or 10 years, you can think about 6 years, because we know that by quick calculation that 3 years is equal to 1000 days, and 6 years is similarly 2000 days. Right? So that means we have to just, so if we want to calculate for 6 years, we have to just multiply 2000 by 20 terabyte. And again, we can do a very quick calculation here. So we can see three zeros here, right? So these three zeros, when they add up to terabyte, it becomes a petabyte. And then this 20 and 2, 40. So that means it's 40 petabyte. Okay. I hope this calculation is clear. If this calculation is not clear, then please raise your hand. Okay, Mithun, the number, so DAU is daily active users, that how many users daily come actively on the system. Daily users doesn't matter here in this calculation. So daily users in this calculation, they don't matter, but in some other calculations they will. We'll see it in the next exercise. Okay. So I'm moving forward to the next exercise. Gustavo, I think your hand is raised from the previous. Do you still have a question? Maybe because you have raised your hand for a long time, and let you. Gustavo, I have unmuted you. Okay, I see a couple of hands. Yeah, if Subbu, if your question is regarding this previous exercise one, then let's talk about it. I have unmuted you. Yeah.
Hi. Not
Yeah.
this exercise, but the previous concept that throughput. So, is a good time to ask, or should I wait?
Yeah, maybe we can take it at the end of the this session.
No problem. Yeah, I can wait.
Thank you. Thank you. Okay, so I'll move to the next exercise. So if 500 million users upload 10 photos per day, how much metadata do we need to keep for several years? So we are designing Instagram here, and then we are finding that 500 million users are coming daily to Instagram, and each person is uploading, let's say, 10 photos per day. So, so how much metadata do I need to keep for several years? So by metadata, we mean the the schema. So, I'll explain it. So we have 500 million users. We have 10 photos per day. Now, how much metadata? Okay. So these photos are being uploaded in some kind of uh, cloud storage, right? Some kind of S3 storage. But we need to keep the metadata in in uh, in our database. So that means we need to have a we need to have a photos table for this. Right? So that table can have a photo ID. It can have a user ID that which user uploaded it, and then let's say it has some timestamp. I know, there could be some many other columns as well, but for the purpose of this exercise, let's keep it these three columns only. When we design photo sharing Instagram, then we'll look into the actual number of columns that are required. Right. Right. So we have this information. We have we have 500 million users. We have 10 photos per day, and we have this idea that this is how my photos table is going to look like. And from this, I have to identify that how much storage this is going to take, right? So the next step is that, okay, for photo ID, so again, the photos are similar to tweets, right? It could be a huge number, a really huge number, right? So we have seen from the previous exercise that a 64-bit a number, that means 8 bytes would be required, ideally required for it. Then for a user ID, we can have 4 bytes. And for timestamp, again, we can have 4 bytes. So this sums up to 16 bytes. So now we have some things to do for calculation. So we know we have 500 million users. They are uploading 10 photos per day. Again, this 16 byte, we can take it as 20. So we have 20 bytes here, right? And since we have to do the calculation for future, right? So again, from the previous exercise, future means 6 years. So a good guesstimate. And 3 years has 1,000 days, so 6 years have 2,000 days. So into 2,000. So we express this into power of tens. Right? So first step is that we identify what all numbers are required for the calculation. Second step is that we express it in power of tens. So 5 into 10 to the power 2 million, again from the power of power table is 10 to the power 6 into 10 into 2 into 10 into 2 into 10 to the power 3. Once we have done that, we count the number of tens here. So 2 plus 6, 8, plus 1, 9, plus 1, 10, plus 3, 13. So we have 10 to the power 13. Then we have 2 into 2, 4 into 5, 20. So we have this number now. Now, the third step is that we have to go to the closest 10 power of 10, which is lower than this. So, so it would be 10 to the power 12. So if I make it 10 to the power 12, that means this will become 200, right? So it becomes 200 into 10 to the power 12. And we know that this is terabyte. So my answer becomes 200 terabyte. So just to store the metadata for 500 million users who are uploading 10 photos per day, so for 6 years, I need to have 200 terabytes. Yeah, we will talk about 70% usage and replication. I am taking gradual steps here. Okay. So exercise 3, it is very similar to the previous exercise. Uh, that you have 3 columns for a user table. So like ID, name, and email. So that is around 100 bytes. 500 million users are there. Right? So how much space will be required by user table for 6 years? So I'll skip over it because it's very similar to the previous one. Sorry. Yeah. Then let's move to the next exercise. So this is where we are calculating the, do we need to use bytes or bits? We need to use bytes. Okay. So if our API takes 100 milliseconds to calculate the response, and we are getting 100,000 requests per second, then how many servers will be needed? So let's do this. So the question is that the API latency is 100 milliseconds and we are getting 100,000 requests per second. So how many servers would be needed? Okay. So the first thing is that we need to identify, the first step here is we have to identify that how many requests are served by one server in 1 second. Right? So, so how many requests will be served? So if it is only one thread, right? So we know that 1 second is 1000 milliseconds. I hope you remember this part. Maybe I'll refresh it again. So we know that one thread is serving one API, right? And let's say it is taking 100 milliseconds. 100 millisecond means the request comes to the thread here. It accepts the request, it does some background processing, and then serves the response. So this part takes, let's say, 100 milliseconds, right? So that means this one thread is able to serve 10 requests per second. Right? So in our case also, we can identify that, okay, 1000 by 100, so 10 requests, but by one thread, right? And we have seen in the numbers to remember, right? We can say that there are 250 threads, right? So we multiply it by 250, so that means 2500 requests per second can be served by one server. Now we know that the requests per second which are expected are 100,000. So we just need to divide 100,000 by 2,500. Right? So this comes to 40. That means if my 40 servers, if they run at 100% CPU capacity, then I'm able to serve 100,000 requests per second. But we have previously seen that we should be running our servers at 50% capacity in terms of CPU. Right? So what we will do is that we'll divide this 40 by 50%, which is so which means if we expand it, 50% is it becomes this, and then this becomes sorry, this becomes just indirectly 80. So it becomes 80. That means we need 80 servers here. Yeah, when we are talking about latency, it's in milliseconds. When we are talking about the data requirements, the granularity is bytes, milliseconds and bytes. Right? So that is why we are dividing it by 50%. So there was a question that why don't we multiply it? So if I multiply 40 with 50%, then it becomes 20, right? So that's why we are dividing it. Now, if I go back to the previous one where we calculated the size of disk requirements, right? So we had identified that 200 maybe I took a fresh one. So we had identified that 200 terabytes are needed to store the metadata. Right. Now this is the assumption that, sure, I'll explain the step one again. So 200 terabytes are needed, and we saw that our disk should be running at 70% capacity. So we divide 200 by 70%. And very rough calculation, we can see that it will be 300 around. So we would be needing, sorry, okay, I messed up. Okay, so 200 terabytes is something we need to store, right? And we saw that one server takes 100 terabyte, right? So that means we need just two servers, 200 by 100. We need just two servers here. And these two servers would be running at 100% disk capacity. So, we need to have some kind of buffer here. So there are two things which first is that you add the buffer here. Right? So you add the buffer. So you divide this 2 by 70%. So this is 3. So you need 3 servers. But you also need to have replication here. So replication factor, right? So the replication factor comes into the picture here. Replication factor. So which is at a minimum it should be 3. What does it mean? That the copy of that the data is, what is a good number for replication? Should we always use 3? Yeah, like a minimum we can take 3. It's good for calculation. Again, like 5, 7, 9. These are very application specific decisions that you will be taking in the real world. So for the purpose of interview, 3 is fine, unless interviewer the discussion with your interviewer goes to some other tangent about the extra reliability or some kind of multi data center applications. In those cases, you can think about some other numbers as well. But 3 is a good number. So replication factor of 3 means that data is copied 3 times. So it will be it's copied on 3 servers. So what we need to do is that okay. So we have identified that 3 servers are needed, right? So we will so in actual we will have 9 servers. Okay. So there was a question on explaining the previous calculations again. So I'll do that. So we know that the latency of one API is 100 milliseconds. This is what we have established with the interviewer. And second thing we have established with the interviewer is that 100,000 requests per second are coming to our system. So first step is we have to identify that how many requests will be served by one server in 1 second. Once we have this number, then we can just extrapolate it. So now we know that 1 second is 1000 milliseconds, right? So I specified here. So 1 second is 1000 milliseconds. And we know that 100 millisecond is being is taken by one API call. So that means my one thread will be able to serve 10 requests per second. And how many threads are there in one server? There are 250 threads that we have seen in the previous important numbers to remember. So that means one commodity server can serve 2000 requests per second. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . I hope this is clear now. Okay. Then this one is an exercise. It is also an important number to remember. Okay, I think for the previous slide, still there is some confusion. Okay, let me explain it again because this is a very important calculation. Let me redo it. Okay, so what we know that. Okay, so let's see. Let's look it from the interview perspective. Right? So you are in the interview. You are designing Instagram. Okay. So you are discussing with the interviewer that okay, I think 100,000 requests per second are coming to the system. So 100,000 requests are coming to the system. Okay. So your interviewer says, yeah, I'm fine with it. So let's say 100,000 requests per second are coming to the system. Then you talk to your interviewer. So we have to serve the, let's say, download API or the view API. So when a user comes to the Instagram and the user is able to see a photograph, right? So this is one API call. Okay, so I think 100 millisecond makes sense here because 100 millisecond is something that is almost real time. It's doable also. So yeah, so interviewer says, yeah, I think 100 millisecond is fine. Let's work with 100 millisecond. Okay. So now you say, okay, I have this number 100,000 requests per second. I know that one API call, right, is taking 100 milliseconds. Okay. Now I need to identify that how many servers will be needed. How many servers will be needed to serve 100,000 requests per second, right? So you look at this calculation from a very granular level first, and then you build upon it. Right? So who serves the API? Yes, a server serves the API, but inside server, it's actually the threads, right? Threads are the execution engine which are serving the API requests. So, you say, okay, so then I need to identify first that how many requests can be served by one thread in 1 second. Right? So, so, so this is how you will build up. So you start with thread. So so you say that the API is taking 100 milliseconds to serve one API, right? And there are 1000 milliseconds in 1 second because because we are talking about these numbers at per second, right? So per second, how many requests are being served? So you say that 1000 milliseconds are there in 1 second, and one API is taking 100 milliseconds. So threads are working constantly; they do not take a break, right? So request one comes to this thread. Let's say it's the name is T1, thread one. The request comes, it takes 100 milliseconds. for the request and for the response. Once this is done, it will get another request. It will take again 100 milliseconds, right? It will serve it back. This way, if if this exercise is done 10 times, right? So 100 milliseconds into 10 is 1000. So this is 1 second. Right? So that means this one thread can serve 10 API requests in a second. I hope this part is clear. So this is where this part is coming, right? Request served by one server in 1 second. So that's why we have 1000 milliseconds divided by 100 milliseconds. So this is 10. So that means one thread is equal to 10 requests per second. So our buildup was from the thread first, then we go at the server level. Okay, now I know that one thread can serve 10 requests per second. How much server can do? Okay, from the previous discussion, I know that one server has 250 threads. So that means I have to just do 250 into 10. That is 2500. So that means one server can cater to 2500 requests per second. Right. Once this is done, now I know, okay, at server level, what is the requirement. Now I will say that, okay, let me extrapolate this. I know what one server is capable of. So I can do a very fair calculation now that how many servers will be required, right? So we know that we have to serve 100,000 requests, and I know that one server can serve 2,500 requests, right? So that means I need 40 servers. And so then you identify number of servers, and then you adjust it for buffer. So this is a servers running at 100% CPU capacity, right? So when we ideally they should be running at 40 or 50%. So let's say 50% for easier calculation. So 40 by 50%. This becomes 80. So we need 80 servers. So Sandeep, these 100,000 requests per second are coming from all the users. So that's why DAU, daily active users count, is not does not matter in this calculation. So the assumption was that, okay, we have 500 million daily active users, and one out of 5 person is uploading one, is sending one request. So from that, sorry, that was for the photo uploaded verdict. But yeah, the 100,000 requests per second is something which is coming from all the users. So like when I'll update it in the slides also. So whenever you want to guesstimate that how many requests would be coming to the server. So in cases of social networks, you can easily take 100,000 requests per second or 200,000 requests per second. Google search gets 60,000 requests per second. So, and I think Google search is very widely used, right? So we can, for Twitter, Instagram, or Facebook kind of thing, we can take 100,000 requests. This can be applied to both read and write requests. Uh, this is the question. So it depends on the nature of the system. So if you are designing social network kind of thing, right? So writes doesn't matter because writes are because the reads could be 1,000 times of writes. So even if we add 100,000 plus we add 1,000. So let me do it. So let's say we have identified that reads are 100,000 requests per second, right? And in that case, what would be the request? If I have a ratio of 1,000 reads to one write, right? So that means it would be what, just 100 writes per second. So if I add 100k plus 100, yeah, we can just ignore this number. Okay, so let's move to the next slide. Yeah, so I was talking about this. So this is an exercise and it is also an important thing to remember. So it is about the availability of your system per day. So you probably know about the 2 nines, 3 nines, 4 nines, 5 nines of availability. And if you are an experienced backend engineer, there are very high chances that someone might be talking about it in your interview. So, so this is how it is done. So 99% availability per day, right? That means 1% times your system was not available. So if there are 100,000 seconds in a day, then 1% of 100,000, that means your system was not available for 1,000 seconds in a day. And if we extrapolate it to a year, then if let's say 360 days are there, in that case it becomes 360,000 seconds per day, which is like 6,000 minutes per year. So with 2 nines of availability, your system was not available for 6,000 minutes in a year. Similarly, if we expand it to 3 nines, so 99% is 2 nines of availability. 99.9%, these are 3 nines of availability. So in that case, it becomes 0.1% of 100,000 requests. Oh, sorry, 1,000 seconds in a day. Sorry, sorry. Um, so 0.1% of 100,000 requests in a day. Right, so that is like 100 seconds per day, and if you calculate it, it's like 600 minutes per year. So if you have 3 nines of availability, that means your system was not available for 600 minutes, which is like 10 hours. So your system was not available for 10 hours in 1 year. So you can do the similar calculation for 4 nines and 5 nines. Because if we take the exact number of 86,400 seconds, then this calculation becomes quite difficult to do in interviews. Yeah, so I'll very quickly summarize, that what do we do with all this information and data, right? So how do we master this? So remember the numbers from previous slides, right? Just learn them. And then during the interview discussion, ask interviewer for the necessary numbers important for the problem at hand. Like how many daily active users are coming, overall how many users are there, what is the latency of the important APIs in the system, and yeah, so these kind of discussions you can have with the interviewer. And many cases interviewers will provide you with the numbers. If you are experienced backend engineer, then interviewer is not going to ask, not going to answer any question. They will just tell you, okay, what do you think? Yeah, then ballpark numbers and estimations are perfectly fine. It doesn't matter if the number of users assumed is 100 million or 500 million. So you can first you should ask interviewers for the necessary numbers. You know. So let's say interviewer says, okay, design Instagram. Then you discuss about the some functional requirements, and then you go to this part and you say, okay, for Instagram, I think there are huge number of users in the world. Do you have any number in the mind which I can work with? Then if interviewer gives you a number, then let's say interviewer tells you, okay, 75 million users. Then you can say, okay, 75 million. Okay, I'll round it up to 100 million users for easier calculation. And if the interviewer does not give you a number, then uh, assume some number and validate. Okay, Mr. Interviewer, I think that 200 million sounds like a good number to me. What do you think? Then they can course correct you if they think that you are not in the vicinity of correctness. Yeah, then master the power of two table and keep doing these conversions in your mind just for fun. Okay, 2 to the power 10 is 1000, 2 to the power 30 is 1 GB, it is 1 billion. Keep doing these reverse calculations in your mind just for fun. Stick all these numbers on your wall and keep revising them. Quiz yourself. If I wake you up in the middle of night and ask you that how many gigabyte data is in 700 million user ID for 8 years, you should be able to answer it within few seconds. Because our target is that we should not waste time on this exercise during the interview. Yeah, and as Master Yoda says that practice, practice, and practice for mastery. Okay, I'll quickly go through some questions now. Yeah, I'll share the slides. I'll share the link with the ops team, and they can share it with you. Then somebody asked, can you explain about mutex lock unlock from previous slide? Yeah, so like you know about the mutexes in coding, right? So so like let's say you enter a discussion with the interviewer uh, that there is some critical section. Let's say you are updating something in database table, right? Or no, let me think of a good example here. Yeah, let's say you are writing a banking application, and then you start discussing that, okay, like for updating the account balances, I will do it in a critical section where I take the mutex log. Then in that case, interviewer can, if you are an experienced backend person, in that case, they can talk to you about this. Okay, what do you think that what will be the side effect of having these logs? Then you can talk about this. Okay, I know that mutex lock unlock takes this much time, and you can build a discussion on that. I'll let Gustavo talk. So, Gustavo, you have your hand raised for a long time. Yes, Gustavo, please go ahead.
Yeah, I have a question. How do you bring up the charting when talking about storage?
Sorry, can you please repeat your question?
I mean, when you're talking about like scaling storage and talking about replication, how do you bring up like a charting?
Sharding. Okay.
Yeah.
Okay. Yeah, so for shard, this is not the right class, Gustavo, for talking about sharding because it is a complex topic. If we start talking about it, will take a lot of time. So I have some material on sharding as well. Uh, so what I'll do is that I'll request ops team, and maybe I'll have a separate discussion on sharding. We can do a floater session on sharding.
Okay, thank you.
Yeah.
I have one question regarding throughput and server response time. So, is both are same or it's different? I'm always confused with the throughput because right now we did the exercise right in that we calculated the throughput, but it seems like that's a server response time.
So your question is that what is throughput?
I mean, what is the difference between throughput and server response time or service time?
Okay, so throughput means that how many requests you are serving. How many units of work your system is able to do in a time period. And to calculate that, we first need to know that what is the cost of 1 unit of work. So in our API example, the 1 unit of work is one API call. And how much time it takes? It takes 100 milliseconds. So from that, we calculated that, okay, the throughput for one thread is 10. Then we extrapolated these numbers.
Okay, what is server response time or service time? Because I in last class also I heard this terminology. I was thinking that okay, when API is executing that whole time, it's called as a service time.
So I think these topics are covered in the fundamentals of system design, the lectures which are given by Omkar, which are I think you can check there.
Okay,
Yes, so
thank you.
Nagarjuna, thank you, Nagarjuna. Nagarjuna also mentioned that these are covered in fundamentals. Yeah, I have also gone through the fundamentals. These are like if you have not seen those fundamental videos, then I guarantee you are missing very important thing in your life, in your journey for system design.
No, I
Omkar
have
has done
seen,
an
but I
amazing
always
job.
confuse with those terms actually, especially the throughput and the service response time. So that's why.
Okay. Okay, in that case, yeah, maybe there are many questions here, so and this is not a common question, so maybe you can take it up in uh, the sessions which happen with the experts, right? So you can talk about that, or maybe I'll share my uh, ID in the end, so you can talk to me also offline.
Okay, thanks.
Thank you. How many years in future we can think of? Yeah, so as like we saw, like 6 years, 9 years, 3 years, the multiple of 3 years is a good number. Why divide by 70%? I hope that is clear now. 64 bits is, yes, it's 8 bytes, yes, it's big integer. Yeah, well done, Madhuri. Yeah, this one we have discussed. We need, I guess we need DAU only to save 1/5 users will get to photos, so that is calculation. Yeah, see, if we are designing any system for users, right? So first we need to have a good estimate at how many users are there. That is the starting point of your discussion. So that's why, like, this is the first number you should discuss with your interviewer. Yes, I'll share the notes. It will be there in the presentations. Also, so how should we divide 40 petabyte among number? Yeah, we discussed this, right? So we are going to divide 40 petabyte by 100 TB because that is what one storage server takes. Uh, there are so many comments and questions. I'm just trying to keep up with it. Okay. We need to use bytes. We should talk in terms of milliseconds. How we are determining the number for ID? So how I determine the number for ID? We discussed this in the starting itself, right? For user ID and for big number ID, how do we do that? Email, yeah, so email and name, you can say that that one character is 1 byte, right? So you can say, okay, 50 characters is good enough for a name, 50 characters is good enough for an email ID. So from there it comes at and one character is 1 byte, so 50 bytes. What is D1, D2, D3? No, so D1, D2, D3 was not data centers. It was just I was trying to tell that data is copied into 3 servers, right? So that's also D1, D2, D3. I use the notation for that. Sorry if I confused you. It was not data centers. Should we also consider replication of app servers similar to having backup? Where did it go? Yeah, yeah. This is a good question, Ranjit. That should we also consider replication of app servers similar to having some backup service? Yes, definitely. You should bring this up in your discussion with interviewer. and ideally, so if your system is very critical system, like leader election system, let's say you have, and in that case, uh, you need to have backup servers, which as soon as the primary fails, they start serving the request. But let's say your service is like a generic API serving service and it's stateless, right? That means the request can go to any server, right? So in that case, you have a load balancer and you have, let's say, 100 servers behind the load balancer. So even if one or two servers go out of the system, you are okay with it. So you don't no need of having replication for all those 100 servers. Yeah, exactly, Sankur. Thank you so much for answering that. So app servers are stateless and they're, yeah, that makes sense. You can replicate for geolocation maybe if required. Yeah, so this is yeah. So like if you start talking about that, what kind of redundancies you are going to have at the data center level, yes, you can talk about it. But often it does not. The discussions do not go to that level. But if it goes there, if you know about it, if you are aware of it, then great. Kudos to you. You can talk about it. In photo or video, should we think about bandwidth calculation as well? Yeah, I have seen these things in the uh, tutorials and everything, but I have never experienced bandwidth calculation during the interviews. Um, yes, you like if you know about it, good. You can if interviewer brings it up, then you can talk about it. But like for me also personally, bandwidth calculations are not that very important unless I'm designing something which is related, very sensitive about the bandwidth, or it's specific to something that. But otherwise, it's not a very necessary topic to talk about. Yeah. So any calculations for network throughput? So again, you can. I'll try to find out the numbers for network throughput. That ideally, what is the throughput? Then you can once you have that number, you can just do the reverse calculation from that. I'll try to find it and update in the slide. But again, I'll go back to my point that it's not a very essential thing to be discussed generally. Can you give example for IO calculations? So Raj, again, this is again a very, I would say, a very niche topic, right? The IO calculations. You know, even if you are a very experienced engineer, if you know the numbers about that, what is the IO rate for a disk, in case you are designing a database, or if you come from from background experience that where you have designed databases, then these things might come up in the interview. But for general purpose, these things wouldn't come in interview. Yeah, so I'll find out these numbers and I can put it in the slide, and you can do the reverse calculation from these numbers. I hope we all are expert in doing the calculations fast now. Yeah, thank you, Sarika, for the feedback. Yes. Yeah, 100,000 requests per second is the throughput, and 100 milliseconds is the latency. Yes. Pratik, I'm not sure what your question is about. Maybe you can rephrase it again. That will be helpful. So are CPU threads different from language threads, or they are same example? Okay, so you generally what happens is that the language threads are mapped one to one with the CPU threads. Not the CPU threads, so the threads at the OS level, the operating system level. Generally, so like Java does that, and in case of Golang, it does not happen. In case of Go language, in one OS thread, many language threads work inside that. So you should know about this thing in your preferred language. So if interviewer brings up this discussion, you are able to discuss about it. But generally in system design interview, nobody is going to talk about it. Maybe not even in a coding interview. Yeah, of course, if the coding interview is about the multi-threading, then yes, it will be discussed at length. Or if it's a language specific interview, then it will be talked about. Thank you, Costa, for answering that. I'll move to questions. I second the request for exercise on streaming. How do we calculate the data transfer rate that with the size of request files? Yeah, I'm not clear like what is being requested here. Uh, 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 Vedinathan, would you be please kind enough to maybe expand on it and send a note to ops team, and I'll request the ops team to provide that note to me, and then I'll have a look into it. Surely, if people are asking for it, then we will do a session on it. Do we need to consider DB sessions limit while calculating? So DB sessions limit. So this is again an advanced topic. Right? So if in a very in a generic system design interview, interviewer won't be asking about it. But if you have on your resume that you have expertise on database, or if the company that you are going to interview, they focus a lot on database, then yes, of course, these things will come into play. These things will be discussed at length. Okay, Mahima, that's a good question. So, first part, yes, I think it's good enough for capacity and scaling planning in interviews. Of course, I mentioned some caveats, like about the network bandwidth, about the DB session limit, and those things. So, if your interview round is about a very niche technology or topic or requirement, then your discussion can go in other directions. But in most of the cases, yes, this is good enough. And should we do it at the last of the interview, is by or okay? So, what happens is that what I've experienced in my interview. So, I used to keep it for the calculation. I used to keep these calculations at the end. And what happened in many cases, that even in my mock interviews also it happened that we crossed our time while discussing the other important things about system design. And then I saw this feedback that I did not discuss the calculations, I did not discuss the numbers. And that was a negative feedback that was coming from me. So that's why I started doing these, I started uh, deriving these calculations, and I start practice them a lot. So now then eventually I started doing at the start of my interviews, and I know that for me it takes only 2 to 4 minutes maximum. And once I've done that, I've seen that okay, interviewers are impressed in the starting itself. Okay, this person knows backend. This person can solve ambiguity. This person can do some well-educated. It can take some well-educated guesses. I can see that, and then that the confidence builds up from there. Yeah. So if you have, as I said, so if you have mastered these calculations, I think by all means you can talk about it at the start of the interview. If interviewer is not interested in it, then interviewer will tell you that okay, let's take these calculations at the end or later on. Yeah. So Vedyanathan has asked, are we assuming databases will be running on commodity servers? If so, isn't yeah. So if you see the uh, distributed databases nowadays, right? So they run on commodity servers. Yes, they are optimized for the disk I/O to an extent, but this 70% is still a rule of thumb. You can take that number that your disk should be filled in that level only. Will regular routing payment ID will suffice us? So I'm not sure about the auto increment ID because it would depend on the database. That database has what kind of data type for that auto increment ID. So you have to check. So again, like if you bring these things in interview, that I think auto increment ID would be sufficient for it. Then interviewer is going to do a deep dive on that. That what database you're talking about, what is the data type, how much bytes it can have. Right? So if you have expertise on that, then only go in that direction. So Pratik has asked question that file systems such as GFS and HDFS use 64 MB and 128 MB of chunk sizes, but are meant for very large files in general. Yeah, so Pratik, the GFS, and I'm not sure about the HDFS, but GFS also, under the hood, the chunk size which is used is 1 MB to 2 MB. Actually, I work in that team, so I know. What should be the upload download ratio for streaming app design? What is a streaming app? Like, can you please explain? Can you give me some example? Streaming app. Okay, okay. By streaming app, you means YouTube or Netflix kind of thing. Yeah. Again, in that case, I think read write ratio would be even bigger, right? So you can see a one popular YouTube video that it is uploaded once, it's seen millions of times. Even the bad videos also, they are seen 5 times or 10 times. Right? So yeah, again you can take 1,000 in that case. A ratio is 1,000. Again, it's no hard and fast rules here. You just have to go with your gut feeling and your common sense, and of course discuss your assumptions with interviewer. That is very important. So, and whenever you are making assumptions, talk to an interviewer that, hey, I'm assuming this. I don't have, you can clearly say that, hey, I don't know about the exact numbers for Twitter or Instagram, but I'm going to take this educated guess here. What do you think? And they will course correct you. Even interviewers won't know those numbers unless it's Instagram and that person works in that department. They would know it. Otherwise, people won't know that. Okay, data streaming is like Kafka streams. Oh, okay, okay, okay. Okay, thank you so much, Kaustubh. I was getting confused. Okay, yeah. So, yeah. So for streaming again, yeah, we are getting some requests for streaming. Let me talk to the product manager who takes care of this system design here. I will talk to her. Duly noted. I've noted it. Okay, then there was a question about hyperthreads. Okay, I'm not very sure about it. I think hyperthreads, they also do context switching actually. So they are optimized for that. So actually, at a time, only one thread is only being executed. So it does the context switching so fast at the CPU level itself that the lag is very less. So it seems to be two threads. That is what I know. I might be wrong, but again, don't bother about these finer details. Yes, if you are an expert about it, if you worked in hyperthreading, you are expert. Talk about it by all means, but don't bring anything into the picture which you are not confident about. It's a buzzword, you have heard about it, you think maybe I can just impress the interviewer, but don't talk about those things in interview. Yes, definitely, Amay. So that's what it was in the slide as well. So if we have a 32 core server and 8 threads per core, then roughly 250 threads per server. Okay, I see a couple of hands raised. Nagarjuna, do you have a question? Unmute you. Please go ahead.
Yes, yeah. Hi, can you hear me?
Yes, I can hear you.
All right, wonderful. So, talking to a few people who recently gave the system design interviews, there seems to be some to be careful being careful about knowing before the hand if it is system design interview or scalable system design interview. In system design interview, you don't focus on all these numbers and all. You just come up with your design, how you design the system. You don't worry about how to scale. So, is this something that we should ask the interviewer before you deep dive into the into those scaling part, or
Yeah,
by default every system design interview we need to go through these scalability requirements?
yeah, that's what my experience is. Generally, it is required as an interviewer. I would also expect it, and so it's unless so it's it's very safe that you should talk this thing with interviewer first.
Okay,
That
before diving into the numbers. Okay.
once you have sorted out the functional requirements, you are in agreement with interviewer. Just ask them, hey, do you think I should do a quick calculations here that how many servers would be needed for 5 years or 10 years, and then if they are interested, they will let you know.
Right. Yeah. Apparently, I mean, recently, talking to one of the colleague, the interviewer was actually upset that he went into these calculations and all, without his, I mean, maybe without his permission, or maybe he was not even expecting that.
Yeah, I don't think it was a permission issue. I think the issue was that maybe that person would have spent more time on that calculation.
Okay.
So let's say there are 45 minutes for an interview, right? So first 5 minutes are for general introduction, making candidate feel comfortable. Last 5 minutes are for any questions. So you have only 35 minutes in an interview, right? Out of
Sure.
those 35 minutes, first 5 minutes you will spend on understanding the question, finding out some functional requirements. Now if you spend next 10 or 15 minutes in doing these calculations, making a lot of mistakes, then of course interviewer does not have good data points about you, because now you are spending only 10-15 minutes on the important aspects of system design.
Okay. So can we also assume that system design and scalable system design are both one and same, or they are used interchangeably?
Okay, so there are some interview loops um, where the low level system design word is used. So it is prevalent in Microsoft especially. So low level system design is that where you assume that there is no database, there is no caching system. You are proposing a system that how you will do it on your own, using your coding skills.
Got it. Sure.
So,
Thank you.
so yeah. So make sure, that's a good question. Uh, make sure that you talk this thing about this with your recruiter first in a very advance. So, like in very advance, you talk to them, you clear it out. Maybe ask for some helpful material as well. Many companies they give helpful materials from which you can get good direction also. And
Okay.
in interview,
You mean with the recruiter itself, not even the interviewer?
yeah, with that, if you ask a recruiter, that means you are asking in 1 or 2 weeks advance, right? Then you have time for focused preparation.
Yeah.
If you go in interview and ask and then ask those things, then you're too late, right?
And I mean to say, maybe the recruiter may not have that much detailed information of
They
what's going on.
they should have. If they don't have, then they are not doing a good job.
Okay.
of data.
Sure.
And they can go to hiring manager, they can go to the person responsible for the recruitments, and they can get those details with you.
Okay. Sure. Thank you.
Yeah, and interviews also, during the interview also, talk to interviewer about your assumptions, your questions. Talk to them frankly. Treat system design interview as a peer discussion. Then if you do that, then a lot of pressure goes off from your shoulders, and you can have much more friendly discussion. I'm
Exactly.
sure you all would have taken interviews, right? So you any day you would choose a person who comes across as a team player, who comes across as a pleasing personality.
Yep.
So be that person. Don't take too much pressure.
All right. Thanks for the suggestion.
Gustavo, do you have a question still? Thank you, everyone. Thank you so much. I see some good feedback. So honestly, it was my first class, so I was a bit nervous, but thank you for being great students here. Thank you so much. And I'll be sharing the slides. Please take some time to share the feedback. It would be really helpful for me personally also. And whatever suggestions you have, pass it to ops team also. I'll take a look into it personally. Thank you, everyone. And yeah, wish you all the best to land your dream job. Bye. Take care. Yeah, sure. Sharding, I will try to do session on sharding.